Chapter 6 Application of Derivatives Exercise 6.2 Fifth question. Find the intervals in which the function f given by f of x is equal to 2x cubed minus 3x squared minus 36x plus 7 is a increasing, b decreasing. So we have given f of x is equal to 2x cubed minus 3x squared minus 36 plus 7. Now differentiating f of x with respect to x, we have f dash of x which is equal to d by dx of 2x cubed minus 3x squared minus 36x plus 7. What is d by dx of 2x cubed? That is 2 into 3x squared. Similarly, d by dx of minus 3x squared, that is 3 into 2x. Similarly, d by dx of 36x, that is minus 36, and d by dx of 7, that is 0. So we have 6x squared minus 6x minus 36, or 6 is taken outside, so x squared minus x minus 6, or 6 into x squared minus x minus 6, it can be written as x minus 3 into x plus 2. That is f dash of x. So let that be the equation number 1. Now, when f dash of x is considered to be 0, so when we are taking f dash of x is equal to 0, we have 6 into x minus 3 into x plus 2, that is equal to 0. Or we can write from that we have x minus 3 into x plus 2 is equal to 0, or we can find x is equal to either 3 or x is equal to minus 2. So we will be drawing a line segment having two points, that is minus 2 and 3 on the line segment. Minus infinity and plus infinity is marked. So now splitting the domain of f into the intervals, that is minus infinity to minus 2. Next one is minus 2 to 3, and the next one is 3 to plus infinity. So first we will be considering the interval minus infinity to minus 2. So now from the interval minus infinity to minus 2, we have the equation for f dash of x, that is 6 into x minus 3 into x plus 2. So from this equation, we can find that 6 is a positive quantity, right? Now x minus 3, if we apply any quantity in between minus infinity to minus 2 instead of x, we will be getting a negative answer. That is x minus 3 is a negative answer. Similarly, the same quantity when it is applied to the x, we will be getting again negative quantity. So we have a positive quantity into negative quantity, that is negative quantity into negative quantity, that is a positive. So we will be having f dash of x as a positive quantity. From that we can say that f of x is strictly increasing in the intervals minus infinity to minus 2. Now we will be considering the next interval, that is minus 2 to 3. So when we will be considering minus 2 to 3, we will be again taking f dash of x, that is equal to 6 into x minus 3 into x plus 2. 6 is a positive quantity. Now we will be putting a value of x in between minus 2 to 3. So it will be we will be having a negative quantity as the answer. Similarly, we are applying the same quantity to the x plus 2 also. We will be having a positive quantity as the answer. So positive into negative, that is negative, negative into positive, again negative. So f dash of x is negative. So we can write f of x is strictly decreasing in the intervals minus 2 to 3. Now the next interval, that is 3 to infinity. Here we will be taking f dash of x, which is equal to 6 into x minus 3 into x plus 2. Similarly, 6 is a positive quantity, and x minus 3, we are applying any value in between 3 to infinity, we will be getting a positive quantity, and similarly x plus 2 also we will be having a positive quantity. So we can write all our positives of dash of x is a positive quantity. So we can write from that f of x is strictly increasing in 3 to infinity interval. So from this we will conclude that f of x is strictly increasing in between the interval 3 to infinity and minus infinity to minus 2. So minus infinity to minus 2 and 3 to infinity strictly increasing. Similarly, f of x is strictly decreasing in only the one interval, that is minus 2 to 3.